Why are soap bubbles colored? If you look at soapy water in a clear container, such as a glass, it does not show the bright hues that bubbles show. To understand the reason for this, it is necessary to know the following: the wave nature of light, the behavior of waves, light reflection from soap bubbles. Let's start with the nature of light. If white light is sent through a prism, it is broken up into the colors of the rainbow. Red light, for example, has twice the wavelength of blue light. Now let's see how waves can interfere with each other. When two waves pass through the same area of space, they combine to produce a new wave. This new wave is the sum of the original waves. If two waves exactly line up when they meet, they produce a wave that is the sum of the original waves. This is called constructive interference. But if two waves are exact opposites when they meet, the result is no disturbance at all. This is called destructive interference. Now let's examine how waves bounce off of obstacles. When a wave passes from a resistive medium to an easier medium, it reflects from the boundary right side up. But when a wave moves from an easy medium to a more resistive medium, it is inverted on reflection. Now let's look at light waves bouncing off a soap film. Watch as blue light strikes a film that is half the wavelength of blue light thick. Some of the light reflects from the outer surface of the film. This wave is inverted since the light is going from air into the film. The wave is descending as it enters the film, so the wave ascends as it reflects. Light reflecting from the inner surface of the film is not inverted because the light is going from soapy water into air. Notice that the two reflections are opposite and therefore cancel. There will be no blue color in this part of the film. Now watch red light in the same thickness of film. Again there is an inverted wave reflected from the outer surface of the film. It combines with the wave reflected from the inner surface to produce a strong reflection of red light from this part of the film. So, if a film is half the wavelength of blue light in thickness, the blue light in the reflection is cancelled, but the red light is reinforced. Now let's examine the case where the film is 1/4 of the wavelength of blue light in thickness. Again there are reflections from the inner and outer surfaces of the film. Notice that in this case the blue light is reflected strongly, but red light is partially cancelled. The reflected light will have a purplish hue in this part of the film. Other film thicknesses result in different colors being reinforced and reflected more strongly. Now, the next time you look at a soap bubble, you will be able to see the contour map of the thickness of the soap film, represented by the colors in the film.